2.4 day 2 of notes is on more application problems. Today we're going to be solving application problems using trig functions, and we're going to select the best method to solve the problems. We're also going to be using bearings to label a triangle's measurements accurately. To start off with, we're going to go over what bearings are. And the bearings of a line L is the acute angle formed by the north-south line. So we're always going to be measuring from either the north or the south line when we're talking about bearings. The notation used to designate the bearing of a line begins with N or S. So it's either going north from the north direction or it's going to be coming from the south direction. And followed by the number of degrees in the angles, and it'll end with east or west to tell us what way they are going. So for example, this segment here, B, is going north 40 degrees east. So we would start from the north line and then we would go 40 degrees in the east direction. Our next example, this has a bearing of north 65 degrees west because we went towards the west direction. And notice those lines are both above the x-axis. Our next one, they're both below the x-axis. So for these two, you're going to notice in their directions, it's going to start with south, 70 degrees east. So we started from the south line and then we went that 70 degrees towards the east. Same thing for our last example. This one, we started at the south and then we went 20 degrees west. So these are what bearings are and how we can use them to draw a line segment. Now we're going to use that in a few examples. So San Luis Obispo, California is 12 miles due north of Grover Beach. If Rio Grande is 4.6 miles due east of Grover Beach, what is the bearing of San Luis Obispo from Rio Grande? So to start, we're going to draw a picture. And we know San Luis is 12 miles due north of Grover Beach. So I'm going to put a point here. That's going to be Grover Beach. And San Luis is going to be up here. And we know the distance between those 2 points is 12 miles. And we know Rio Grande is 4.6 miles due east of Grover Beach. So that one is going to be 4.6 miles over here. And because we know San Luis is due north and Rio Grande is due east, that tells us this is a right angle. And what they want us to find is the bearing of San Luis from Rio Grande. So when we're finding the bearing from here, this is going to be where our north and our south line is going to be. And we need to figure out what the bearing is going to be to this segment there. So we are looking for that angle. In order to figure out what that is, we can use this right triangle we've drawn to find this angle, and we'll use that to then find theta, which will be our bearings. So using that angle down here, we have the opposite side and we have the adjacent side. So we're going to use the inverse tangent of 12 over 4.6, and that's going to give us what x equals. So using that, we're going to be able to figure out what x equals, and then we can figure out what theta is from there. So I'm going to type that into my calculator. 12 divided by 4.6, and we're going to get about 69.0. and that is what is equal to x. And this is going to be forming a right angle here again. So to figure out what theta is, we're going to take 90 minus x, or in this case, 90 minus 69 degrees. And that will give us 21 degrees. Now we're going to use that to write the bearings for our answer. So our bearings have to start with a north or south. So looking from our north-south line, it is on the north part. So our answer is going to start with north. And then we're going to put the angle we found, which is 21 degrees. And then if we were going east or west, remember, east is going to the right, west is going to the left. So in this one, we went west. And that is how you would write your answers working with bearings. All right, let's do another example. For this one, a boat travels on a course of bearings north 52 degrees and 40 minutes east for a distance of 238 miles. How many miles north and how many miles east has the boat traveled? So we're going to start, my screen moved, with our axes. That'll be our north, south, east, and west. And they told us that the boat traveled on a bearings of north 52 degrees and 40 minutes east. So that's going to be about right there. And we know this angle is 52 degrees and 40 minutes. And the total distance they went was 238 miles. So that is going to be representing the length, 238 miles. They want us to figure out how far north and how far east this boat has traveled. So we're going to form a right triangle with our positive x-axis. And using this angle that they gave us for the bearing, we're going to be able to figure out this smaller angle inside of the triangle. So we're going to take 90 degrees minus 52 degrees and 40 minutes. And if you remember back, 1 degree is equal to 60 minutes. So we're going to go ahead and borrow a degree and then subtract. So we're going to have 37 degrees and 20 minutes. And to type this into our calculator, we need this to be in degree decimals. So I'm going to divide this by 60. And we're going to get 37.3 repeating for our degrees down here. Now we can use SOHCAHTOA to figure out our missing side lengths. We are going to be looking for the length that we went on the X and on the Y. Using our right triangle, if I find X first, that is the adjacent side, and we know that the hypotenuse length is given. So I'm going to use cosine of 37.3 repeating is equal to x over 238. Then we will solve this problem to figure out the estimated answer of x. So we'll take 238 times the cosine of 37 and to get 37.33 repeating, you could probably put, let's see, 1, 2, 3, 4, 5, 6 threes in your calculator, and then your answer will be pretty accurate. So this one, 238, perfect. So we will get about 189.2, and this is represented in miles. Then we'll do the same thing, except with sine, to figure out what our y value is. So we're going to solve this almost the same way, where we're going to multiply both sides by 238. And we're going to put about 5 3s there to get our answer. And this would be about 144.3 miles. And that is our y value. I always recommend drawing a picture for these problems and then using that diagram to help you find your answers. So always make sure you start with a picture. Next we have example 10. So example 7. In figure 10 below, it has a diagram of how Diane estimates the height of a flagpole. She can't measure the distance between herself and the flagpole directly because there is a fence in the way. So she stands at point A, facing the pole, and finds the angle of elevation from point A to the top of the pole to be 61.7 degrees. So that's from the ground going up to the top of the pole. Then she turns 90 degrees and walks 25 feet to point B, where she measures the angle between her path and the base of the pole. She finds the angle to be 54.5. So this is on the ground. It's not going up to the top of the pole like the first angle is. It's an angle formed on the ground. They want us to use this information to find the height of the pole. So we have 2 different right triangles here. One is on the ground here. And I'm going to draw that off to the side so it's not being overlapped by anything. So we have point A, B, and C. And we know between A and B that's 25 feet. At the angle formed at B is 54.5. And then we are going to need a second length in our triangle that's going up to the top of the flagpole. So if you look at this one, we have CD, and that's the height that we're looking for, and angle A, which is 61.7 degrees, and we have X here, which is also the same length that is a second side on our first triangle. If we look at our second triangle, we don't have enough information to figure out what H or X is equal to. But if we look at the first triangle, the yellow one that I've drawn, that one has enough information where we should be able to find what X is equal to. Because X is the opposite side and 25 is our adjacent. So if we use this, we can do the tangent of 54.5 degrees is equal to X over 25. Then you can solve the problem by multiplying both sides by 25. And that can be typed directly into our calculator to estimate the values. And normally this is where we would type that in, but just to make sure that we get the exact value at the end, I am going to leave it as 25 tangent of 54.5 equals X. And that's what I'm going to use down here for the X value. So instead of this, I'm going to put 25 tangent of 54.5. And this way, our final answer is going to be the most accurate because we haven't rounded multiple times. So again, we are working with the opposite and the adjacent side of our second triangle. So we're going to do tangent of 61.7 degrees, and that'll be equal to H over 25 tangent of 54.5. Then we'll multiply both sides by that value again. And we will end up with our answer. So now that this is our final step, we're going to type this into our calculator, and because we didn't round it at all yet, our answer should be as accurate as we can get it to be. So we're going to do the tangent of 61.7, and we're going to divide that by 25 tangent of 54.5. Now make sure if you're typing this into TI-84 and you're not using the fraction function, that you put, oh, I did this wrong. I'm sorry, we're supposed to be multiplying, not dividing. Sorry about that. So I guess ignore that, you won't need parentheses because you are multiplying this. So 25 times the tangent of 54.5 equals. So we would get the height of the flagpole to be about 65.1. And this one they were measuring in feet. So don't forget your labels. And that's how we can use trig to estimate the height of an object, even if we're unable to actually measure to that object. So go ahead and you can start the homework assignment. If you have any questions, let me know. Today you're just going to be doing number 15 through 22. And tomorrow we'll go over any questions that you have. Have a good day.